right. Welcome back, everyone, to MDE 54. This should be week 3, lecture 2, amongst the entire series of lectures and everything. We are going to do mostly just traditional math material today, a lot of order of operations type stuff. There's going to be 2 problems, at least, if when I recorded it, if that's what I can remember. I was watching it earlier to remind myself as well, but there's going to be a problem where I make an unintentional mistake later, and I like to leave those in because I think it's good for everybody to see how we can learn things and correct things. And again, that nobody's perfect. And then I have another question where I do have intentional mistake and an intentional mistake. I'm having a hard time phrasing words right now. But yeah, I mean, like I've said, I will always throw intentional mistakes in the lectures, and anytime I make an accidental mistake, I will always leave that in as well, because again, it's good to remind ourselves that we're all human and we learn from our mistakes. I would like to remind you that I am using these assignments as your attendance. It doesn't mean you have to complete 100% of each assignment, but you have to put in some amount of effort. And I've never said a specific grade because I don't want everybody just aiming for a 50 or just aiming for a 60 or just aiming for a 70. Effort is effort. Effort to one person might be an 85, effort to another person might be a 69, effort to another person might be 100. I just want to see time invested in this. And remember that if you're not doing these assignments, even though they're not going to give you an A, B, C, D, F grade, that means you're not, quote, attending class with this online format. And that means that you can be withdrawn from the course, and a withdrawal from 54 also withdraws you from 154. This is not something I want to have to do. So please just keep up with your work. So again, we're going to do some order of operations stuff now that I've got my math lab acting a little better, or my computer acting a little better, whichever it was. And per usual, if you see a due date, I just kind of kept on the Word files as I was doing these. If you see that, it's usually what I have these blinders for. Just ignore it. And yeah, so I'll be in the chat in a few minutes if you have any questions, but let's begin.
Which is some questions from both of these week 3 sections. And I do want to remind you that your attendance is going to be loosely based on just some participation. It's like I said, it doesn't have to be everything. I know 1 or 2 of you are getting like 80s and 90s on these, and that's great. But I've got a lot of people who aren't doing any of this yet, and I've got a few people who are hardly doing anything yet. So please understand, if you're not doing any of these at all, that is counting as lack of attendance. So please do something, and not just 1 or 2, do a decent amount. I'm not asking for half necessarily, but just do something that's an understandable and reasonable amount. Most of these questions aren't too complicated, especially with things like the note-taking skills, the study skills, the reading to learn. A lot of those are just multiple choice. You can, I mean, I don't want to say you could do it blind, but because it's multiple choice and you have infinitely many attempts, I'll let you answer that question. But still, those things have good information. So, put in the time, put in the effort. All right. So I want to focus on the math side of things first, per usual. And we're going to be doing some more order of operations for like the first half of this, and then it starts getting into fractions, which I know is everybody's favorite. So we'll make sure we get some of those. And I'm going to try and get this set up for that, and then we'll do this. All right, so again, PEMDAS, PEMDAS, PEMDAS. PEMDAS, not MDAS. P is its own step, parentheses. E is its own step, exponents. M and D is its own step, multiplication and division. Addition and subtraction is its own step, 1, 2, 3, 4. When you're handling your multiplications and divisions, you're doing them from left to right. If you see a division and then you see a multiplication, you do them in that order. So if I saw 10 divided by 2 times 11, yes, M, the letter, comes before D in PEMDAS, but that has nothing to do with anything. M and D count as their own step. So you would do the division first and the multiplication seconds. You have got to take your time, you've got to pay attention, and you've got to have this concept memorized. So 10 divided by 2 would be 5, and then your 5 times your 11 would be 55. And that is the correct answer. If you did it the wrong way, 10 divided by 2 times 11, you would say 2 times 11 is 22. And you do 10 divided by 22, and you say, well, 10 divided by 22 is going to be a really ugly number if you pull out a calculator for that. I have one. 10 divided by 22, and you could take the time to do the long division, but that's not the point of this course. 0.454545. But usually, we're not going to want to answer things that way. What we probably want this as is a reduced fraction. So you'd say, okay, we'll turn this into 10 on top of 22, and then you say that 2 goes into 10 5 times, and 2 goes into 22 11 times, getting an answer of 5/11ths, which this is the decimal version of 5/11ths, but again, it is still wrong, wrong, wrong. This top version was the correct way. What we did wrong here is we did this first and this second, which was not supposed to have been done. Bad, scribble out. Just because the letter M comes before the letter D does not mean do that step first. Multiplication and division are two sides of the same coin, and by coin I mean step. Same for addition and subtraction. So you can take that knowledge and you can go and be social media gurus and teach the ways of things, but I'm sure you'll have someone stubbornly argue with you and say that M comes before D, so it's done first, and they'll think they're right. And that's just life, and you can't have a heart attack over it. So you just gotta hope that maybe someone will encourage them to seek out the correct knowledge at some point. Maybe in Mr. Beckner's math class. All right, so being reminded of those steps, and we're also being reminded that just because you have a parentheses doesn't mean it counts as a parentheses. In this problem right here, that is not a parentheses of a 4 because there's nothing going on inside of it. It's just a 4. This is just a -5. This is just a -6. There's no operations inside of the parentheses. These parentheses are simply used to denote a multiplication, like in the first one, or kind of taking care of your negatives because they can kind of muddy things up without that. Like this might look like -5 minus 6 without those parentheses set up. And without the first parentheses, writing plus minus just looks a little confusing. Now, yes, that could have been written as minus and then 5 times -6. But I trailed off. But that's, there's a lot of different ways this can be written. That's not the point of this. All right, so let's get to it. Number 1. So we have, that was weird. It's okay. -9, black for starting it, -9 times 4 plus -5 times -6. So PEMDAS, P-E-M-D-A-S, there are no parentheses counting as parentheses. There are no exponents at all in this. So we're on the M and D. There are 2 multiplications so that we do them in the order we see from left to right. All good, don't worry about that. Welcome aboard. So we're gonna do the first product first. -9 times 4, we've gone over those sign rules. 9 times 4 is 36. But when you're multiplying opposite sign numbers in pairs, the answer is negative. Now, technically, because of this addition, you can do that second product all at once, but I am being meticulous. I am taking my time, trying to make sure we don't make any mistakes anywhere. So now I'm going to do the -5 times the -6. 2 negatives make a positive under multiplication and division, so that's a positive 30. So this is -36 plus 30. And then -36 plus 30 with addition and subtraction, the rules are same sign, add the numbers, keep the sign. If they're different signs, subtract the numbers and keep the sign of the larger. If you don't remember that, go back to the previous lecture where we wrote those notes down in a longer fashion. Or the internet somewhere else, wherever you have to. So 36 minus 30, because they're opposites, I'm going to subtract them, which is 6. The negative number has the larger absolute number, so that means the result is -6. Let's see if we get it right. -6. We got it, so we can move on. All right. So a little sidetrack from the order of operations stuff. Words. Math 154 is full of words, isn't it? You've already seen how wordy it gets, and we are just starting off things 3 weeks in, the end of 3 weeks in. So there are going to be times when you have to translate things from a sentence to a mathematical expression or an equation. So it is important to understand how these work. Now, I think that most people understand the words like sum and product and added to and divided and things like that. This one in particular, though, this use of the word from, in particular with subtraction, what this does is it reverses the order. So saying from reverses the order of the values seen. So in other words, saying 7 subtracted in, this is not going to be 7 minus in, it is actually in minus 7. So this from phrase will be littered throughout the semester, so be prepared to see that. If you see something is subtracted from or taken away from. So that translation, and we don't have a number here. It's not asking for a numerical answer. It's asking for what is 7 subtracted from in. And if you don't trust me, here's 7 minus in. Let's check the answer. Let's see what it says. You have translated in subtracted from 7 instead of 7 subtracted from in. That's actually a pretty good hint. So it was supposed to be in minus 7. Oops. There we go. Translate into an algebraic expression, which is the same thing we just did. 24 more than some number. Now you have to pay attention in general. When we say some number, that could be X or Y or A or Q or R or whatever letter you like. But my math lab can't accept just some random letter. They tell you which one to use. So they say let M or N, represent our some number. More than means to add. 5 more than 10 would be 5 plus 10, which is 15, because 10 and then 5 more. So 25 more than some number would be 25 plus that number. So 25, and then I do plus X, and I'm rushing, and I check my answer, and they say it's not right. They say more than corresponds to addition. That's a pretty good hint. It's actually not what's wrong with what we have up here, and that might be confusing if you don't pay attention. But what we did wrong was we used our generic X, which we usually like to do, instead of what my math lab told us to do, which was to use in. Now, let me hit similar question. Notice that time I answered 25 plus n. I'm going to hit similar question. This time it says 21, so the answer would be 21 plus n. If I do 21 plus n, that will be the correct answer. Let's see if I can swap the order of them, though. The subtraction one we couldn't, and that's because 5 minus 7 is very different from 7 minus 5. But under addition, 5 plus 7 is the same as 7 plus 5. The order doesn't really matter. So let's see if my math lab cares about that, if I swap the order here. In plus 21, what did I do wrong? Let's see if anyone catches that. I actually want to see if the chat will catch it, because I did that intentionally. What did I do wrong? If it's in plus 21, if they're not telling me the order is in the wrong, they're still saying it's addition. Wasn't that the same thing they told me last time when I used X instead of in? Well, last time it was in, it should probably be in again, right? In plus 21. Uh-oh. We didn't pay attention, did we? Let D represent the number. So let's see if D plus 21 will work. And it does. So it would have taken 21 plus D or D plus 21. I tried to mislead you with the wrong letter, but we can see that we got the right answer. All right, back to some PEMDAS. These little curly brackets and these brackets are all the same thing as parentheses. They're just different visually so that the problem doesn't look like this. This problem that you see over here for number 4 would be the same as if I wrote parentheses, parentheses, oh, go away, Apple, parentheses, 12 minus 17, close the first one, minus 2, close the second one, minus 4, close the third one squared. That's the same problem as doing curly bracket, bracket parentheses, 12 minus 17, close the parentheses, minus 2, close the bracket, minus 4, close the curly bracket, and square it. They're the same thing. One of them just stands out a little more visually, at least in my opinion. When you get these nested parentheses like this, it could be easy to get lost in them and think that you closed them all. If there was a fourth one, you know, maybe it was supposed to be like this. I'm missing a closed one though, so that's not very correct. Now, I want to point out something. This can be put in your calculator as it sits, this first line, and at the end of this problem, I will show that. But you can't put it in most calculators this way because most standard calculators like your TI-30s and your TI-83s and 84s and whatever, they don't have curly brackets and brackets that operate in the way that I'm telling you they're supposed to operate. Your TI-83s and your normal graphing and scientific calculators think these brackets are what we call matrices, which is something above our pay grade for this course. You may have seen them in the past, and they can be simple, but they can also be complicated. But we're not doing matrices in here. The curly bracket is just notation that a calculator's not going to like. So if you wanted to put this in your calculator, you would have to do it this top way, and you'd have to understand that it's the same as the bottom way. But we're focusing on our arithmetic skills, so parentheses, step 1, P. Well, got lots of them. Go to the innermost being this 12 minus 17. So that should be the first step. So let's leave the curly bracket. Let's leave the bracket. 12 minus 17, well, that's subtraction. So we take the larger minus the smaller. 17 minus 12 is 5. Keep the sign of the larger, so negative 5. Now that number's a negative inside of this parentheses right here, just the blue. And then there's a minus 2 here, and we close the bracket. Maybe because this was negative, you wanted it in parentheses. Still, it doesn't count as a parentheses, but it's just a visual aid maybe. I don't know. It's up to you. I'm going to leave it off personally because there's no product of it. If there was a product, it would feel more necessary. So that's all I'm doing. Again, if you want the parentheses, put it there. Now, we're still under the P step, parentheses, which counts as this bracket, negative 5 minus 2. So we go equals, curly bracket, negative 5 minus 2, those are the same sign, so we add and keep the sign. 5 plus 2 is 7, keep the sign, so negative, and that was the bracket. Then there's the minus 4, and then we close the curly bracket. Now there's clearly only one step to finish this up, and I have missed one detail. I was seeing if someone would put it in the chat or not. The exponent of a 2. This is a very easy thing to miss, so I intentionally left it off here, but it really should be there. That would have given us a wrong answer ultimately. So we're still in parentheses step, so we're doing this negative 7 minus 4, same sign, add the numbers, keep the sign, which is negative 11. Now you might say, okay, it's just a single number and then the exponent of a 2, we're not going to forget it this time. If you write it this way, this is wrong. Now, maybe you get the right answer because you do this step wrong and 2 wrongs make a right in this particular instance, but you're not going to get that lucky all semester. Because the exponent was supposed to be applied to everything inside of the curly bracket, this negative 11's inside it, you still need that curly bracket or parentheses, however you want to write it. Because negative 11 squared with the parentheses is different than it would be without it, and we've discussed that in class already. Because this case repeats it. Negative 11 times negative 11, which would be, drum roll, positive 121. So let's see if that gives us the right answer. 121. How about that? We got it right. So I'm going to put a little note here, reminding of what I just said. Note that the negative 7 minus 4, when it was squared, is not equal to negative 11 squared without the parentheses. And this was because negative 11 squared that way is just a negative written once, and then 11 times 11, which would have been negative 121, and clearly my math lab didn't do the math wrong. This will be an issue all semester that you have to get a firm grasp on. Oh boy, look at all those steps. lots of places to have accidents and mistakes and wrong orders of things. All right, number 5. We got 7 plus 4, that's a division symbol. I know it might be a little small. Then 2.2 plus 6 all over, which counts as the division. And remember, we simplify the tops and bottoms before we cross that division bar. 6 squared minus 3 squared, then times a 3, minus 2 minus 7. Let's make sure we got all that right. I know I made a mistake translating, or maybe like in the second step last class or 2 classes ago. 7 plus 4 divided by 2 times 2 plus 6. 6 squared minus 3 squared times 3 minus 2 minus 7. Cool. PEMDAS, 4 steps, not 6. P, parentheses. There are no parentheses written here. Technically speaking, again, the way we think of fractions when they've got a bunch of steps top and bottom, there's an imaginary parentheses here, which is why we have to do the entire top by itself, the entire bottom by itself, and then we can do the division. And when we say top and bottom, we're doing them in the appropriate PEMDAS steps. So in the top, we have an addition, a division, a multiplication, and an addition. So there's no more parentheses, there's no exponents. So the first step we're doing in the top is going to be, we have division and multiplication. So we have these two things. And we're going to do the multiplication first, right? Question mark, inflection, and voice? No. Multiplication and division done from left to right in the order seen. So the division should be first, and the multiplication should be second in the top. So in that top, we're going to leave the 7 in the plus. The 4 divided by the 2 is going to be a 2, then times a 2 plus 6. Now you might say, Mr. Beckner, you're not following PEMDAS. There's exponents in the bottom. The top and bottom are their own entities. So you can do PEMDAS in the top completely separate from doing PEMDAS in the bottom. So in fact, I'm going to simplify the top to a single number before even touching the bottom. I could simultaneously be simplifying the bottom. I could be saying, all right, I see 6 squared. There's our exponents of 36. And then a 3 squared, so I'd simplify that and keep crunching along at the same pace. I'm just going to do the top completely and then the bottom completely. If you want to work on top and bottom simultaneously, that is up to you. So I'm just going to write B for bottom, just so I can save myself some sanity for a little while. Now we do the multiplication. 2 times 2 is 4, so 7 plus 4 plus 6 all over bottom. It's 2 additions. Do them from left to right. Technically, addition order doesn't matter as long as they're all additions. 7 plus 4 is 11. 11 plus 6 is 17. Same thing if you did 4 plus 6 is 10, plus 7 is 17. When it's all additions, order doesn't matter. When it's all multiplications, order doesn't matter. But when you mix things like subtractions or divisions or all sorts of other craziness, order absolutely matters. So 17 over the bottom. Now that the top is a single number, let's rewrite the bottom of 6 squared minus 3 squared times 3 minus 2 minus 7. Now let's do PEMDAS in the bottom. We have 2 different exponents, 6 squared being 6 times 6, which is 36. So 17 over 36 minus 3 squared times 3 minus 2 minus 7. Now this 3 squared, this minus is not repeated. We just rediscussed that issue, like the negative 11 squared without a parentheses around it, the negative's not repeated. That's just 3 times 3. This 3 squared is just 9. There's still the minus in front of it. So 17 over 36, the minus that was in front of it. Here is the 3 squared, which is 9, times the 3 that was after it, minus the 2, minus the 7. Still the 17 in the top. Now in the bottom, subtraction, multiplication, subtraction, subtraction. So P and E are done. It's M and D that we're up to. We only have one multiplication. The 9 times the 3 would be a 27. So that's 36 minus 27, minus 2, minus 7. We have a bunch of subtractions. We better do them in the order from left to right. As I said, you can add in whatever order you like. Subtractions must go left to right. 36 minus 27 is going to be 9. So 17 over 9 minus 27 minus 2 minus 7. I'm double checking some things just to make sure we haven't made any silly mistakes. All right, then the 9 minus 27, those are opposite signs. So we subtract. 27 minus 9 is 18, but the negative 27 had the larger sign. So this would be 17 over negative 18 minus the 2 minus the 7. We're almost done. 17 over negative 18 minus 2, same sign, add and keep the sign, makes negative 20 minus the 7. Negative 20 minus 7, same sign, add the numbers, keep the sign, so that's negative 27. Now, I'm not a fan of leaving negatives in denominators. This is not really okay in general. We need to have the negative in front of the fraction, like so. This is the exact same thing. Or we need to have the negative in the top, like this. These are the two versions that would be acceptable. So let's see if we get it right. Let's see if we didn't make any errors anywhere. And they say, fill in the answer box, so nothing about fractions. So negative 17 divided by 27 is reduced as much as possible. One or more of your responses is incorrect. So where did we go wrong? 7 plus the 4 divided by the 2. 4 divided by 2 is 2. 2 times 2 is 4. The top should be 17. 6 squared is 36. Oh, I see where we went wrong. I wrote the minus 27 right twice. I knew something looked goofy. When I got here, that's why I was like, I'm looking back. Something doesn't look right. I had the 36 minus the 9 times 3. This 9 times 3 was this 27. Then 36 minus 27 was supposed to be this 9, but I wrote this again. Blah. So that was supposed to be 9 minus 2. So let's just take this part and start over. Let's fix it. 17 over 9 minus 2 minus 7. 9 minus 2 would be 7. So 17 over 7 minus 7. 7 minus 7 is 0. And this is where students may get a little confused. And I don't mean just students at our level, I mean students up to and including calculus. Whether this answer is supposed to be 0 or undefined. So the question is, which is it? Is 0 divided by anything 0, or is anything divided by 0, 0? Which is it? Well, it's undefined. You cannot divide by 0. Sorry about that. But it did bring up an important point that I don't like dividing by negatives in answers. That was still relative, but this was more about showing that 0 divided by anything is 0. When I say anything, I mean that can be any number, 5, a million, 3.7, except 0. We're not worried about 0 divided by 0. That's known as the indeterminate form. That's above the QR pay grade. And that anything divided by 0 is equal to undefined. This number does not exist. It's not real. It's not imaginary either, if you've ever heard of the imaginary numbers. If you really want to know the technical, the complex version of this, it's both infinity and negative infinity at the same time. And that just sounds mind-boggling, which is exactly why it doesn't exist. It's undefined. You can never divide by 0. Now, this is not generally going to be an issue in quantitative reasoning, but the other side of it will be that 0 divided by anything is always 0. So let's see if we can get this right now. Now, when I switch it to B, that answer is grayed out. Hopefully that doesn't affect it. Shouldn't. And there we go. Now we got it right. Sorry about that mistake. All right, and we said we would put this in a calculator to show that this works. Now, I have to know how to put this in a calculator, because if I just type it the way it says on the screen, a lot of things are going to go wrong, because this 7 plus 4 divided by 2 times 2 plus 6 is the top of a fraction. Remember I mentioned at the beginning of the problem that with fractions there are implied parentheses around them? That's how you actually have to put it in your calculator. So we go parentheses, 7 plus 4 divided by 2 times 2 plus 6, then you close the parentheses for the top of the fraction. Now the fraction bar, you have to do another division, so this is counting as that fraction bar. Fractions are divisions. Then to do the bottom, I have to know to open another parentheses. 6 squared minus 3 squared times 3 minus 2 minus 7. We close our parentheses, and we hit enter, and it says error, divide by 0. So error divide by 0 means it's undefined. They're telling you that that problem was going to divide by 0, which is why the answer is undefined. I also said I'd show the previous example, this one, the one with all the parentheses and brackets and such. So if I do that in my calculator, remember we have to do the triple parentheses. 12 minus 17. Close the first parentheses, then a minus 2. Close the second parentheses, then a minus 4. Close the third parentheses. That whole thing was being squared. This is my exponent key on a TI-83. You may have a key if you're dealing with like a TI-30 that has an X raised to a Y. I'll write down what that looks like. You see this X squared right here? It would look like that, except it would be a Y. That would be your exponent key if you don't have this upside down V known as a caret. So I can do it that way, or I could have just hit the square button. And we get the same answer that we originally saw. So we can use our calculators to confirm this stuff. And I know you'll be using calculators regularly through the semester, but it is still important that you have these basic arithmetic skills, that we're paying attention, and when we get answers that don't make sense, we check them like I did earlier, because like I always point out, nobody's perfect. All right. Next up, expression evaluation. Something that, again, we'll see all throughout this course. I would say most of this course and its Excel use is all about function evaluation. It's just we're making Excel do it for us. So what they do is they give us something with letters and numbers, and they'll tell us what numbers to substitute in. Kind of like when we have the heart rate and they tell us to substitute an age of 10 years old, 20 years old, 30 years old. You're just turning the variables into those numbers and seeing what you get out of it. Now, when you're plugging in negatives, you should wrap them in parentheses in general. There we go. So let's try that one out. 6, 4x squared plus 5y cubed minus 11 with x equal to 1 and y equal to -3. They're telling you which one is which. It's not the order. It doesn't have to be an x and then a y first. These could have been swapped. So I'm going to use colors to show you my substitution. I'll do blue for the x value and red for the y value. So this will be equal to 4 times, now the x is being squared. Now because it's positive, I don't have to wrap it in a parentheses. So there's my 1. But this y, since it's negative, I don't want to do dot and then -3 and then cube it like this. That looks weird, that looks wacky, and it can give you wrong answers. You want to make sure you're wrapping your -3 in parentheses, then cubing it, then your -11. Now here's what some people will do. They'll say 4 times 1 is 4, 5 times -3 is -15, then they'll square and cube those numbers, and that's wrong because PEMDAS. Exponents come before multiplication, so don't do the 4 times 1, do the 1 squared, which is 1. So That's 4 times 1 plus 5 times negative 3 cubed. Again, I could have gone ahead and simplified it, but I'm waiting. So it's 4 times 1 plus 5 times negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Now we've handled the exponents, we're ready to move on to the multiplications. Yes, exponents are technically multiplications, but they're repeated multiplications, and it's that repetition that gives them the leg up on everything else. 4 times 1 is 4, plus 5 times negative 27, minus 11. 4 plus 5 is 9, right? Inflection? No, that would be wrong because I'm doing an addition before multiplication. I'm just trying to do things from left to right. Pay attention to PEMDAS though. And I won't lead us down a long path since I actually made a mistake in the last example, which again, I apologize for. 4 plus, we got to do 5 times negative 27. And if these are getting too big for you, remember you can pull out a calculator. It's not the end of the world. It's not my favorite thing to see, but 5 times 27, I'm not going to show the negative part. Be 135. That's positive times the negative, so the answer should be negative. I'll show it now. 5 times negative 27 confirms our negative 135. So that's 4 plus negative 135. Alternatively, you could have written 4 minus 135, not 4 minus negative 135, not that. 4 minus 135. Then minus our 11. Looks good. That's a 4. That was our negative 27. That's our negative 135. Minus 11. No typos, no mistakes. Good. 4 plus negative 135. So we have an addition and subtraction. Do them from left to right in the order you see. These are different signs. 135 minus 4 is 131. The larger number is negative, so keep it negative. Then the minus 11. These are the same signs, so we add and keep the sign. So negative 142. Let's see if we get that right. In fact, let's use our calculator to confirm it before we even put it in. Maybe we're just scared. So the 4x squared, that would be 4 times 1 squared. Then plus 5 times the y cubed. Now I have to wrap that in parentheses because of the negative and to make sure that the cube is applied to the negative as well. Then the minus 11. Let's see. Negative 142, we got negative 142 here, sounds pretty good. So I think this will be right. How about that? It is. We'll do one more of these and then I'm gonna move ahead to something else. This is number 7. 4, and I'm not gonna rewrite the problem. I'm just gonna go ahead and inject the numbers. 4, parentheses a plus b squared, then plus 5, parentheses a plus b, then a minus 8. A is 4, b is negative 1. So we're going to go 4, parentheses, a plus b, that's 4 plus negative 1. So that's the a and the b. I put an extra parentheses in there because of the negative. Close the real parentheses and square it. Then the plus 5. Then that parentheses is also a plus b, so another 4 plus negative 1. Close the parentheses for the 5. And then the minus 8 at the end. Now we have parentheses, we have exponents, we got some multiplications, additions, and subtractions. Parentheses go first. So we'll be doing this first. Now this is exactly the same thing. So 4 plus negative 1, that's going to be 3. I am going to go ahead and do both of those replacements. So this is 4 times positive 3. I don't need the parentheses because it's positive. Don't forget the exponent. Then plus a 5 times 3 minus 8. Again, I went ahead and did 2 steps for 1 there. No more parentheses, we're up to exponents. Do not multiply 4 and 3 first. You have to square first. E before M and D. 3 squared is 9. So that's 4 times 9 plus 5 times 3 minus 8. 4 times 9 is 36. Minus 5 times 3 minus 8. 5 times 3 is 15. So that's 36 minus 15 minus 8. 2 subtractions, do them from left to right. 36 minus 15 is 21. 21 minus 8 is going to be 13. Do we trust me or not? No, we made a mistake. Where might the mistake be? I love doing this. I'm sorry. I know I'm mean about this sometimes. Where could our mistake have been? Well, we try and find it, right? 4, a plus b squared. 5, a plus b minus 8. A is 4, the b is -1. So the 4 plus the -1 should be a 3. So that's 4 times 3 squared, and then a 5 times a 3. We have our -8. All right, then we do our exponents. So that should be the 9. 4 times 9 plus 5 times 3 minus 8. The 4 times the 9 gave us a 36. The 5 times a 3 gave us a 15. Do we see the mistake yet? Come on, I see it. I mean, I knew where it was. I did it intentionally. It's right here. This was 4 times 9 plus 5 times 3. But then we switched it to a subtraction. So all we got to do is fix that to a plus. So let's make that a plus. So that should be a plus 15. And then all we got to do is just correct these last couple lines. So 36 plus 15, let's see what we get. 41, 51. And then 51 minus 8 should give us 43. All right, hopefully Mr. Beckner is done taking us. Let's see if we get it right this time. All right, we did. Now, I know it's funny that I did one of these accidentally earlier, but I had intended to do it on this one. But again, this is what happens, and I literally proved that by doing it myself. We have to learn how to go back to our work, and this is why we show our work, because without showing all these layers of detail, it would have been way more difficult for me to find the error. But finding errors is one of the many important aspects of quantitative reasoning. Getting an answer that doesn't make sense and going back and trying to fix it, whether it's in Excel, whether it's in your My Math Lab homework, whether it's outside in the real world. Oh man, I just bought this $5 item and a $7 item, but when I got rung up at the cashier, they charged me $33.50. Why did my $5 item and $7 item end up costing me $33? That seems really weird, right? It's probably because someone accidentally rang things up multiple times. Or it's because you thought something was priced one way and it was priced another. Now, that could be because the item was on the wrong shelf or the wrong placement. I can't tell you how many times that's happened to me at Kroger. Hey, I think this item's $2. Nope, it's $3.50. But that's life, right? Things like that happen. Things don't always go perfectly in life. Just look at the technology that we deal with. Zoom, my math lab, my internet. And if that isn't the perfect time, it heard me. It heard me say that. Okay, so where were the next ones we wanted? 11. I'm gonna skip a few at a time because I don't remember which number the fractions start at. I forgot to write that down. I have little notes for this stuff, but I didn't write what number the fractions start just to make sure we do the fractions. Digits, we've done that. Yeah, my math lab's still running a little slow. It was doing better when we started. Digits. This is fun. Someone else said they noticed the lag is back. More digits. All right. Where did they start? Thank you for your patience as always. And remember, if you have anything that you want to address in this class, you can email me ahead of time, not 10 minutes ahead of time. I need 24 hours notice. But if there's something that you want me to address, I am more than happy to. Here we go, finally, getting to some fraction stuff. All right, so write a fraction to represent the shaded part of a figure. So when you have a shape like this, they're trying to say that this whole shape, if this whole thing was red, that would be one whole. But they're dividing it into different sections, and these can be circles or squares or any type of shape in the world, triangles, octagons, decagons, heptagons. Here we got the octagon. 2 math problems go in, 1 come out. So we have 1, 2, 3, 4, 5 red sections shaded. So it's 5 out of something. And there are 1, 2, 3, 4, 5, 6, 7, 8 total. So that means that the fraction that represents the shaded part, we want to hit this key to get our fraction. Go to the top, type of 5, bottom, 8. Now please understand that in general, if this were a reducible fraction, in other words, if there was a number that divides evenly into the top and bottom, that you should reduce any fraction in this course unless told otherwise. Generally speaking, you reduce. Did we get it right? Good. All right, but what about when you have 2 of the same shape next to each other? You don't have to be sitting directly next to each other, or 3 or 4 of the same shape. Each of these shapes represents one whole. So if both of these were completely shaded, it would not be one whole, it would be 2 wholes. So this is where we get into mixed numbers or improper fractions. So with mixed numbers, we're saying that one whole, we're dividing them 4 ways. So that would be 4/4 or 1 whole. But then we have another one that has 1 out of the 4 shapes shaded. So the mixed number version of this, we want to click the mixed number one, would be 1 and 1/4. The big one on the left is these 4 pieces making up 1 whole. And then on this one, there were 1/4 shaded. 1 of the 4 were shaded. Just so you know, before I hit enter, I want to show you the mixed number version of this. I'm going to do it over here on the left. 1 and 1/4, I don't know why that 1 didn't register at first, would be the same thing as 5/4. The left number is known as a mixed number. The right number is called improper. And it's not improper like it's resting its elbows on the dinner table at some fancy restaurant or something like that. It's just one of those weird situations where a math name is funny. An improper fraction is any whole fraction or more. So a proper fraction is less than 1 whole, and improper is a whole or more. So even 1 whole, 4/4, would be improper. And it's not because it reduces, it's because it would be a whole or more. 2/4 would reduce, but it would be proper. How do we go between these two things? To go from mixed to improper, you're going to multiply the 1 and the 4. So you multiply the 1 and the 4 first, and then you will take the 4 and you will add it to the 1 second, and that's how you get the new top. 1 times 4 is 4, plus 1 is 5. How do you go from improper to mixed? You use long division with a remainder. So you would put the 4 on the left, the 5 on the right. You'd say 4 goes into 5 once. 1 times 4 is 4. Subtract and you get 1. Now under normal, decimals, you'd put a decimal here and a 0 and bring the 0 down and say 4 goes into 10 twice. But when we're converting to a mixed number, we would stop. This is your remainder. The remainder is the new top. The quotient is the whole. So this would be your whole, and this would be your, and that's not a, let me make that R just a little cleaner. It looks like a 12. There we go. This would be your new top. All right, that wasn't the point of this problem, but I wanted to make sure that was addressed. Just in case this keeps happening. All right, another one like that. Identify the mixed number represented by the shaded region. Note that each oval represents 1 copy of the figure, in other words, 1 whole. So this is a whole, this is a whole, this is a whole, this is a whole. So 1, 2, 3, 4 holes, and then this one is divided into halves, into 2, one of which is shaded. So the mixed number would be 4 and 1/2. So make sure you click the mixed number icon. This is not something that comes up in QR a lot in mixed numbers, but it could at any point because you're supposed to have that process down. And we check it, and we got it right. Incidentally, if you took 4 times 2, you would get 8. 8 plus 1 is 9. meaning that the improper fraction would be 9/2. Also, this could be written as a decimal of 4.5. All three of those answers are correct. As long as MyMathLab doesn't want a specific format, it wouldn't care, but very often they do express which format to answer. Find two fractions equivalent to the following fraction. This is important for when you need to add and subtract fractions. Again, not a skill that's used a ton in this class, but will be used periodically, semi-periodically, if you will. So this is what you do. Actually, I want to do that in black. When you want to take a fraction like 1/4, maybe you have to get an LCD. You need a common denominator to add or subtract fractions. And you determine that the LCD is 12. So this is your new denominator. We generally like making denominators our LCDs when adding and subtracting. You will divide these two numbers, and I don't mean 4 divided by 12, I mean the division that you would actually do. You would say 12 divided by 4. And then after that, so that would be the first step. The second step is you take whatever you get after that and you multiply by that 1. That's your second step. So laid out directly, we say 12 divided by 4 is equal to 3. We take that number, that 3, and we multiply it by the original top. We're dividing the bottoms and multiplying by the top. I'm going to say it again for the people in the back. We're dividing the bottoms and then multiplying by the top. We're dividing the bottoms and then we're multiplying by the top. What are we doing? We are dividing the bottoms and then we multiply by the top. Don't ever forget that again. So that says that that top would be 3/12. You can reduce to check this. Reducing, again, just means find the biggest number that goes into both of those, top and bottom. So 3/12, 3 goes into both of those. 3 goes into 3 once, 3 goes into 12 4 times, so this would be 1/4. Maybe you don't show your work that way. Maybe you do it this way. Maybe you show division by 3, division by 3. Just a little lengthier way of writing it. 3 divided by 3 is 1. 12 divided by 3 is 4. Same answer either way. Make sure it's right. Hopefully our teacher didn't lead us down a wrong path. All right. So we did that, but then, oh no, they gave us another one. Find two fractions equivalent to 1/4. So now they want to know 1/4 would be equal to what over 20? So maybe we're adding or subtracting, and our new denominator needs to be a 20 so that they all match and thus all able to add or subtract. LCDs aren't needed for multiplying and dividing, just adding and subtracting. So this time what we're going to do is we're going to say divide the bottoms, 20 divided by 4 would be 5, and then multiply by the top. 5 times 1 would be 5. So again, for this new problem, we're taking 20 divided by 4, which is 5. We take that result and we multiply it by what was in the top originally. 5 times 1 is 5. And if you reduced 5/20ths, 5 goes into 5 once, 5 goes into 24 times. It works. This is the same problem, basically, but you might need more practice, so I gave 2. Let's say this attempt. Write an equivalent fraction, same thing, 5 goes into 10 twice, 2 times 4 is 8, but there's only one of them, so I'll do this one. Divide and multiply. It's as easy as that. That's how you get an LCD. Another one for more practice. 12 will go into 36 3 times. 3 times 7 is 21, so that would have been my answer. Remember, your problems will be different most of the time. You'll have different numbers. Same type of problem, just different numbers. Arrange in increasing order. So in order to order, pun intended, fractions, they all have to have the same denominator. So it's not just adding and subtracting that you need an LCD for. It's also if you want to compare their size. To add, subtract, compare size, fractions, you need an LCD. I'm going to maximize this for, well, do it that way. There we go. This is the smallest number that divide the original denominators into. You can use prime factorization. You can use listing the multiples until you see a match. Or whatever alternate method works for you. But those two are the primary methods. Some people say just multiply the denominators. As long as they don't have any common factors, that works. This example you see on the screen, they're all divisible by 3, so it would fail miserably. Prime factorization is like writing the 9 as 3 times 3, the 18 as 2 times 3 times 3, and then this is 3. And then your LCD is just a product of all those primes. So you need the 2, and then you need the pair of 3s. Why does that keep popping up? Listing the multiples means with the 9, you go 9, 18, 27, 36. With the 18, you go 18, 36, 54. With the 3, you go 3, 6, 9, 12, 15, 18, 21, 24, etc. Until you see a match with all of those, which would have been 18. So for the 9, you go 9, 18, 27, etc. For the 18, you go 18, 36, 54, etc. For the 3, 3, 6, 9, 12, 15, 18, 18, 18, 18. First match out of all of them, so the LCD is 18. I'm not saying this is the most efficient method always. That's just the way I chose to show my work for this. I verbally said the work for the other one. In fact, I will show it. The 9 was 3 times 3. The 18 would be 2 times 3 times 3. And the 3 is just 3. Your LCD, you need all of the different unique factors, which are 2s and 3s, but you take the most out of the options. So you need a single 2 and a pair of 3s. Now I could circle this one, or I can circle this one, but not in both. So our LCD is 2 times 3 times 3, which is 18. Same answer. And if you're rusty with this stuff, these are skills you're supposed to already have. You'll need to practice on your own. There are some problems in here. You've got that Purple Math Khan Academy. It's pretty easy to find stuff on getting common denominators outside of this course. But that's not the whole problem. That just gives us the new denominators. All these 9s, 18s, and 3s need to be turned into 18s. So the 4 over 9, we need to turn into something over 18. The 5 over 18, we need to turn into something over 18. And the 2 over 3, we need to turn into something over 18. Well, the middle one's easy. The bottom are the same, so that number should be 5. 18 goes in 18 once, 1 times 5 is 5. The denominators don't change, the top can't change. For the middle one, 18 divided by 9 is 2. Then we take that 2 and multiply it by the 4, which is 8. So that one would be 8. This one would be 5. For the last one, 18 divided by 3 is 6. 6 times 2 is 12. So there's our equivalent fractions. We have 8 18ths, 5 18ths, and 12 18ths. Yes, 2 of these reduce, but if you reduce them, you're walking in a circle. We were supposed to build these up so we could have added or subtracted them if they asked us to do, which they didn't. We just wanted to order them in increasing order, so smallest to largest. The bottoms are all the same, so all we got to do is compare the tops. So this is the smallest, 5. 8 would be the middle, the medium, and 12 would be the largest. But we're not supposed to write them that way. We're supposed to write them with the original numbers. So we have to know that 5 18ths was, well, the 5 18ths. Let's make a fraction. 5 over 18. You need to hit right, and then a comma, because they said to separate by a comma. Then the next one would be the 8/18, which was really the 4/9. So fraction 4/9. Hit right, then comma. If I don't hit right, the comma goes with the 9 and it'll give you a wrong answer. That's syntax errors. And believe me, it's frustrating when you make syntax errors. And then the last one would be the 2/3. So 2 divided by 3. Looks good. Hopefully everything's okay. We did it. Good job, team. If I had to add or subtract these at that point, let's pretend that was add 8 plus 5 is 13, 13 plus 12 is 25, and then you can reduce if you have to. More the same. I think they all were pretty much more the same. So we're going to go ahead and converting to a decimal. I mean, you can just feel free to type those in a calculator. There's nothing wrong with that. But the real trick is if your denominator is a power of 10, you don't have to do the division. You can just say it's that many decimal places. So 9/10. It keeps pulling up today. That's weird. There's one decimal place. I'm sorry, there's 1 0. So we need to have one decimal place, and it would just be 0.9 or 0.9. You don't have to write the 0, but it's just better notation. All right, I only got about 8 minutes left, so let's move to the other type of stuff. The reading to learn. That first one's got a video, so we're not going to do that together. We did this one together last time. I'm still here. All right. Craig is writing a short paper for his health class about kickboxing as an exercise. This has nothing to do with QR. That's not the point. He read this information about why kickboxing is healthy. 1. Kickboxing is a martial art that involves punching and kicking that many people use as a form of exercise. 2. Kickboxing is an effective cardiovascular exercise. 3. People should focus on their cardiovascular fitness 3 to 5 days per week in short intervals. 4. Cardiovascular exercise such as kickboxing strengthen the heart and lungs and promote the flow of blood and oxygen to muscles throughout the body. Which sentence from this source should Craig highlight to include in his paper? All right, and then there's just 4 sentences to pick from. So let's go back and reread everything now that we know what the question is, what we're looking for. So he's writing a short paper for his health class about kickboxing as an exercise. And we want to know which sentence from his source should he highlight to include in this paper. Kickboxing is a martial art that involves punching and kicking that many use as a form of exercise. I highlighted too much there. That could be good. Kickboxing is an effective cardiovascular exercise. I mean, that's fine too. People should focus on their cardiovascular fitness 3 to 5 days per week in short intervals. So that doesn't say anything about kickboxing, so I'd probably not do that one. Is it a good fact? Yes. But if we're just highlighting one sentence, it doesn't say kickboxing, so maybe that's not it. Number 4, cardiovascular exercise such as kickboxing strengthens the heart and lung and promotes the flow of blood and oxygen to muscles throughout the body. So let's see. We got someone that says D, which is sentence 4, and they're even jerks, and it doesn't go 1, 2, 3 if you're rushing. It goes 3, 1, 2 here. I bet if I did it wrong enough, it would resort it. So someone said sentence 4, that cardiovascular exercise such as kickboxing strengthens the hearts and lungs and promotes the flow of blood and oxygen to the muscle throughout the body. So that seems to touch on a couple of different concepts. Maybe it's right, maybe it's not, and it is. So highlighting the information related to the research project will help Craig skim through his source quickly. Now, is that saying that sentence 1, 2, and 3 are trash? No, it just seems to kind of tie everything together. Kickboxing is a martial art that involves punching and kicking that many people use as a form of exercise. That's pretty generic, and I would assume that most people would already know that. How many people don't know kickboxing involves punching and kicking, right? So it's not a great sentence to highlight. Kickboxing is an effective cardiovascular exercise. That's cool, but sentence 4 also takes care of that. Sentence 3 we already tossed out because it doesn't even mention kickboxing at all. So 2's cool, but 4 is better. 1 is cool, but very generic and something that you would probably already know and don't need to highlight. That's why sentence 4 works. Mustafa, now I got Lion King in my head, is studying for his economics class. Or is it Mufasa? It was Mufasa. Sorry for that. Just where did my brain go? He has read, let me start over since I just got distracted. Mustafa is studying for his economics class. He has read the chapter and highlighted and annotated his textbook. He has also copied his annotations into a list of notes. What should Mustafa do next? So all of these things are good. First, he went and highlighted and annotated simple things. Then he took those and made them into his own notes. So a much smaller collection of ideas, a much more focused collection of ideas. So what should he do next? Should he reread the entire chapter? Photocopy the entire chapter, which is arguably maybe not legal. Combine text notes and class notes, or highlight minor details in a different color. Anybody got any opinions? I mean, I already kind of hinted that photocopy's probably not it. I'm getting some D's and C's, that's about what I expected. Rereading the entire chapter would be good, but I feel like if you've already done all this, that's probably taken care of. So combine notes and, combine text notes and class notes, or highlight minor details in a different color. I like both of those. Let's try C. So the highlighting in minor detail is a great idea, having yellow for main ideas and then like a magenta for sub ideas or secondary ideas. So there's nothing wrong with D. I wanted to just go ahead and start talking about that. Well, I knew C was going to be right. But yeah, combining the class notes and the text notes into one set would put everything in a more, well, combined format, obviously. Alyssa is creating an outline from her highlighted textbook. The outline thus far is given below. Click the icon to view a portion of her highlighted text. Click this icon to view her outline. What should Alyssa write next to number 3? Lack of exercise, excessive alcohol, unhealthy habits, or unavoidable circumstances. Obviously C, right? Well, no, we can't say any of these. We haven't clicked anything. So let's see if this one is different from this one. And it is, like it should be. So here's the textbook. Let me maximize this so we can get everything up here. And then Alyssa's outline. Perfect. So she was creating this outline from the textbook from the highlighting sentences. The outline thus far is given below. So here's the textbook, here's the outline. What should she write next to the number 3? So the first thing she has is hereditary. Then she has linked to disease. And then step 3, and there's nothing to scroll down because there's no subs yet. No A, no B, no C. So for the hereditary, we have it based on history and ethnicity, linked to diseases, so different inherited issues, sometimes like diabetes, and diabetes is not always inherited, but you can inherit the likelihood of getting it. Chronic kidney disease, adrenal and thyroid disorders, again, those could be genetic or not, just depends. So we're talking about hereditary issues, linking to other diseases. What else do we have? Several circumstances can cause high blood pressure. So hereditary, links to other diseases, and then a third thing. So we have the hereditary stuff, we have the diseases. The next thing that's highlighted looks like she highlighted people who are obese and don't exercise are more likely to develop high blood pressure. People who smoke or drink more than 1 or 2 alcoholic drinks per day are at high risk. Excessive salt, stress, old age. So this is a main idea, not a sub idea. So main idea, lack of exercise seems like a sub idea. Excessive alcohol seems like a sub idea. Unavoidable circumstances like stress and old age seems like a sub idea. Unhealthy habits would be a collection of lack of exercise, excessive alcohol, and unavoidable circumstances. So let's see if that's going to work. There we go. Gary annotates his textbook with these notes. Ask the professor about this part. I tell you what, that is a great thing to do right there. Put some, I don't know what he was talking about that day, 5 minutes into the lecture, write a little note, email Mr. Beckner about this, or, a text response in the chat, something like that. But if I don't have time to get to you, then you email. So what is the purpose of Gary's annotation? To identify a main idea, to remember what section confused him, to point out unknown terms, or to connect a personal experience. It's clearly D, right? Ha ha ha. Does it seem like it's to identify a main idea? I don't know. That sounds kind of weak if we're just asking a professor about this part. So it's probably remember which section confused him or to point out unknown terms. It could go either way. Let's try unknown terms. So that was wrong. Unknown terms and definitions are important to write, but Gary's annotation is not related to the main idea. So probably to remember which section confused him. Yes, he's confused about a section. Ask about this section. It seemed a little clearer, but I still thought that C might be one that some people think. All right, this will be our last one. Rob has a test in 2 days and not much time to study. Shell suggests, I hope I pronounced that right, if not, oh well, Shell suggests taking notes, and Rob replies, I just want to get through this. Facts of life, right? What advice should Shell give him? So, test in 2 days, not a lot of time to study. Someone suggests taking notes, and then Rob says, well, I don't have a lot of time, I just want to get through this. I don't want to take notes. What advice should Shell give him? Taking notes to save time by reducing what Rob has to study. Maybe those notes will help him so he's not flipping through 50 or 100 pages of a textbook, just 3 pages of notes. It seems like a good, solid advice. Highlight important material and try to memorize it as he highlights. That also seems like a good suggestion, but is it too late to be doing that step of things? I don't know. Read all the material aloud as many times as he can before the test. That's a good idea, but it might only work for people where talking things through or reading out loud actually helps them learn. Not everyone learns that way. Read materials slowly and carefully without taking notes because that is the most efficient. If you don't learn by writing, maybe, but again, there's a maybe there. So it seemed like it was probably A or B. I think we'd agree. Highlight important material and try to memorize it as he highlights, or take notes to save time by reducing what Rob has to study. A seems like a more blanket scenario, and that's the one that works. Again, B was a good suggestion, but it's just a very minor suggestion, and that should be the very first thing that's done. This is something that should have been done a couple weeks ago. But if you have the time, which Rob doesn't, it could have been helpful. Someone else might also say that this is just is a part of taking notes, which I could argue is true. But these are all shades of gray. So we got through some of those. Like I said, it's never my intention to get through all of them. They're there for you to try on your own. Please try them on your own. Again, you're not getting tested on this stuff. Your life is your test of this type of material. It's the math parts that are more directly affected inside of the other class, but having good study skills, understanding the importance of reading and taking notes. These are all important aspects that will still help you succeed. So on that.
So on that note, we're going to be sorry about that. On that note, we're going to be calling it a day. Please remember that you are responsible for doing something at a minimum. I will be withdrawing students very, 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 very soon for anyone who has not done anything inside of the MDE My Math Lab course. So please take that seriously. Besides that, take care, and we will see you next time.